attends gross month to 250 wages, and then 15 is little, 50% is 12%. So this is our total.
So guys, here's a little something that would help with that 3B. Believe it or not. So this is not that situation at all. Here's the idea. Everybody cool with what this represents possibly? We've done things like this before. We just didn't call it probability. We call it relative frequency. So this is like the number of TVs somebody owns. I ask people, how many TVs do you own? So 11% of the people said they have no TV. 39% said they had one TV. You guys with me? 5% had 4. They have the one in the bathroom so they don't miss out on what the soccer score is or whatever. You guys, everybody with me? And I said, what's the probability? Now, what do these all add up to be? You can double check it, but what do they have to add up to be?
100.
Yeah, 1. Or 100%. 11. Now, they all add up to be 1. Okay. All right. So watch this. So that what did we just say? The probability is 0 plus probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 equals 1. So then if I ask you, what's the probability of at least 1? To do it directly, you would just add these up, right? But what's another way to do it? Here's the probability of at least 1. I can subtract the 1 that I left out. The probability of at least 1 is 1 minus the opposite, which is the probability of none. Anytime the opposite situation has less work to do, I'm going to do that. So the first step is sort of like you're saying, screw you and your question. I'm going to answer the opposite question. Nah. But then you do 1 minus, and then it actually answers the question. Probably it's going to rain today, 5%. What's probably it's not going to rain? 95, 1 minus. We know that already. So if we calculate the probability of the opposite situation, then do 1 minus that, we're answering the question. Mathematically, it only frickin' makes sense. If they all add to 1, 1 minus a chunk is the other chunk. Maybe. So that gives you a way to do 3B. The problem with 3B, if you wanted to calculate it directly, what does it mean that at least one of them think the chocolate milk comes from brown cows? At least one. So it could be the first one. Or it could be the second one. Or it could be the third, or it could be the fourth, or it could be the first 2. At least one is 2, or it could be the middle 2, or the first one and the third one, or the first one and the last one, or the third one, or it could be 3 of them, or it could be all 4. So you could do all those probabilities, add them all up. Have fun. I ain't doing that shit. I'd much rather go, the opposite of at least 1 is none. There's only one calculation to do for the probability of none, and then do 1 minus that. Be smart about it. If the opposite situation has less calculations, dear God, I'm going to do it that way. This is going to happen a lot to us in this class. It's not always going to be this phrase, at least 1, but it will be that phrase most often. If somebody says, what's probably of at least 1, I immediately think, let me see the probability of none, and do 1 minus that. I like it. Maybe. All right, so let's look at this whole thing. Let's see. Come back up here. So let me catch up to you guys real quick. Let's see. How quick are you going to be, Jeff? Is that right? 176? Yep. Thank God. Okay. So I start off really nice. But probably they attend Grossmont. So it'll be 126 attend Grossmont out of 176 people, which is what? 159? Mm-hmm. Okay. Business major. These don't build on each other. Totally separate situation. I kind of reset here. Business major would be 92 business majors out of 176, which is
0.5227.
0.5227. Okay. Yeah. All right. Thank you, guys. Now here's our first little tweak. Computer science or attends Grossmont. So they attend Grossmont. I could do 126 plus 73, but then I'd have to subtract 62. Or I could be smart about it and say 126 plus 11 which one is it? Yeah. Plus 11 computer science majors I haven't counted yet. Either way you do it, you get 137 out of 176, which is 7784. Okay. I like it. All right. So it's probably they're a math major and a Cuyamaca student. This is where everybody, not everybody, but a lot of people try to use a formula here. That would be so disgusting. Again, and this is so weird for math students. This is always true, but you never get to really use this fact. You don't always have to use the formula if there's a quicker way. So if I have the ability to count all the situations, I'm not going to use any freaking formula. Right? We developed the formulas based on what we did when I had a situation we could just count. So how many are both math and Cuyamaca students? 2. Out of?
176.
Still 176. The only problem in here that's going to have a different bottom is going to be probably the last one we haven't done, E, because it's a given. The only time the bottom changes is if I give you more information, because then you can throw people out. It's like, I know it wasn't you, get out of here. Right? What the hell is 2 out of 176? Oh, 0.0113?
Yes.
Okay, thank you. And then you can make it a percent after that if you want to. I love it. Given their computer science major, so now what's on the bottom?
73.
Yeah, so my whole world is this. So out of those 73, how many go to Grossmont?
62.
62, and what's that?
0.8493.
0.8493?
Yeah.
Okay. How you guys doing? Yes, yes? Okay. So our being a Grossmont student and a computer science major, independent events, you've got to remind yourself, if you start to write a little paragraph and there's no numbers in your little paragraph, you are wrong. Stop yourself. Start with the numbers and then do something after that. It's a very mathematical idea. So what do I want to compare? I made you guys do the work already. So the problems that involve Grossmont computer science are here and here. So the probability they're a Grossmont student is almost 72% chance. If I know they're a computer science major, does that affect the probability they're a Grossmont student? Yes, it goes up quite a bit. 85% chance, almost. So you don't have to know that much as it go up or down, but you have to know, and you can just see, oh, it changes. So the probability, so you say, are they independent? No. Probability of Grossmont does not equal probability of Grossmont given computer science. 0.7159 does not equal 0.8493, and I know that last statement is groundbreaking, but answer, idea, numbers. I love it. I hope to God that idea, if I want to know if two things affect each other, I probably have to look at a probability that shows the interaction between the two. I can't just say probably Grossmont is not the same as probably computer science. Where's the effect? Where's the interaction between the two things? There isn't any. You have to include that given idea to see. So hopeful. So this is something that actually relates to us on a biological level. All right, you ready? So even now. So I have an example from like way back when. So let's say that you have a lot of caveman friends. And, sorry, we're back in caveman times. And you notice that the cavemen that go a certain path don't come back. So if you start to walk back and you have a choice between that path and a different path, probably not going to take the path where people don't seem to come back. More than likely, they're dying somehow horribly, getting eaten alive. I don't want to experience that, even as not a caveman, right? So the probability that I live is affected by the path I take. So of course it's going to affect me. Living in San Diego, there's a really good example of this that doesn't involve death most of the time. Is if I'm in a certain location at a certain time, I'm not going to leave. I'm going to just stay there for a bit because I know like about 3:30 to 6:30, if you are in certain locations, screw trying to get anywhere, right? So, yeah. Some of you guys live this. Some of you guys have different time periods depending on where you live, but you know those times. You're like, oh, we missed the window. Might as well just stay here for a while. Or, you know, you just go out there knowing you're going to be sitting in traffic, so you're like, let me pull up the old solitaire, or whatever the hell you do, right? You guys kind of with me? So we live this idea of independent versus dependent. Given that it's a certain time of day, what's probably I get home quickly. Okay, right? Then you work with it with result. Yes? We didn't go drill down to numbers, but we know that one affects the other one in quite a drastic way. So it affects our decision. Yes, yes, yes? Okay, maybe. On a more specific level, let's say that every time that oil is discovered, there's a certain type of sand. Or not every single time, but most of the time, there's a certain kind of sand, and then they find oil. So they go back. They never realized it at first. They're like, you know what? Every time we found oil, there's a certain kind of sand. So then you go out, and there's like 5 different places to look at, and one of them has that kind of sand. I'm going to look there first, right? Because the probability I will find oil there is higher based on past experience. Are you guys kind of with me? That one I stole from an old teacher of mine from forever ago. And they actually had numbers and all this kind of stuff, but oh well. Too bad for me. I didn't do the research. Okay, all right. Maybe. Am I recording this at all? No. It's not necessary. Oh, man. Let's not. This is very true. This is very, not true, but very apt statement. We've got to save them and save our own oil. All right. This next one, I don't know. If you don't like movies or Target or Target or Panda Express, then you're not really interested. But if we pick one card out of this box, what's probably is an AMC gift card? This one's not too bad. How many cards are there? 23, right? 23? So there's going to be 8 out of 23. What is that?
3, 4, 7, 8.
3, 4, 7, 8? Okay, I like it. By the way, I am kind of crowdsourcing these answers, but I always get people that don't round correctly. What I do is if you have several of those issues, I start to take off a point for like every 3. You got to know how to round. Okay. What's probably a Target gift card? 11 out of 20. Yeah, these are nice, easy problems. And what's that? 4792? 82. 83. All right, lower. Okay. All right. Now we take 2 cards with replacements. So the first one's AMC is still going to be 8 out of 23. And I put that one back in, so Panda would be 4 out of 23 still. Still 23 cards. I didn't lose any cards. And what the hell's that? 0605. And then 2 cards for Target. So Target's going to be a couple of 11 out of 23s. And that's going to be like 0.21. I don't know. What is that?
2287.
2287. Okay, I can live with that. Okay, I like it. And I always do this. I ask you the same questions without replacement. So it's basically going to be the same thing. What's going to change on the next one, though?
Denominator.
Yeah, I still have all 4 Panda cards, but I got 1 less card. And whatever the hell that is. 0632. So you can already see how little that changed. Yeah. 2 cards for Target. What would happen now? 11 out of 23 for the first one. The biggest mistake I see is somebody puts a 9 here, or even somebody puts a... What if somebody put like a... See if you guys can figure out this mistake. What if somebody put like a... What do you got, Jeff? 10 out of 12. Yeah, I know. I don't see this